So under this section, we are going to look at some of the faults that we may encounter during the usage of a gas turbine. Okay, so some common faults that could happen, or problems that could happen in the course of the operational life of the gas turbine is reduced power. That is, it is not delivering as much power as expected or as it is designed for to our load. Okay. Then 2, increase exhaust temperature. That will mean that not enough energy is extracted from the hot combustion product that is going through the turbine to the exhaust section. Okay, so that affects the efficiency of our gas turbine. So we are going to look at some of the things that could cause increased exhaust temperature, gas temperature, and what we can do to remedy the situation. Then compressor issues. In our earlier section, we discussed the basic function of the compressor, which is to generate the compressed gas that we needed in the combustion or the combustor, okay, or the combustion chamber of the gas turbine. Then combustor issues, okay, how it can affect the operations of the gas turbine. Then the turbine blade issue, the turbine itself, the blades, okay, especially the rotating blades that are very prone to problems every now and then. So we are going to look at them too and see some of the issues that they will be having. Then the bearings. The bearing function is, apart from supporting the load, is to aid the rotation or movement between rotating parts, okay, and the stationary part. So if they are faulty, it means that that function, which is basic to the operations of the gas turbine, will not be achieved or could be affected. Remember, all we are doing is to generate that rotating mechanical energy or power that we will need on our load or for our load. Then the control system problems, okay, can affect the operations also. Then the cooling system, as you saw in the functioning of the gas turbine, a lot of heat is generated. So this heat needs to be taken out of the gas turbine, or else that will cause damages to the components of the gas turbine. So the cooling system, once they have issues, it means that the gas turbine will definitely have issues. Then the lubrication system, okay, since we have rotating parts or meshing parts that rub on each other, those surfaces need to be lubricated. So the system that takes care of this, once they have issues, the frictional force at those points will go up and then cause problems. So let us look at these common faults one after the other. We are first going to be looking at the reduced power output. So when we say reduced power output, it means that the power that is expected, or the energy that is expected from the gas turbine, is not being delivered or could not be delivered by the gas turbine, or we are having something less than what is expected from the gas turbine. So which means that the load will not be properly powered, okay, or that will cause the derating of the entire unit since the power output has been reduced. So what could be the possible cause? One is the fuel system, okay. So once we have issues from the fuel system, in the fuel system, what we say the fuel system, we are looking at from the source of the fuel storage, to the nozzle where it is injected and combusted within the combustor. of the gas turbine. So everything on that line constitutes the fuel system. So once there are issues, okay, that can cause reduced power. So here you see a typical fuel system, okay. See it to the gas turbine, then from your source, your fuel source. So we have components in the fuel system. These are control valves, okay. So all of these valves, and then these are filters and separator filters. We have two. Are you getting it? So all of these filters, these valves, and all of these control elements, okay, all of them put together constitute the fuel system. So if this flow meter or this particular flow meter or this valve is malfunctioning, what will happen is that it will affect the amount of fuel that is being delivered to the gas turbine. If this filter is plugged, it will also affect the quantity, the amount of fuel, and the quality of fuel that will be delivered to your gas turbine. That is, if these filters are not too effective. If any of these they are malfunctioning, okay, this pressure safety valve, I mean to say, if it's malfunctioning, it will also affect the amount of fuel, okay, that is sent to the gas turbine. So we are going to look at all of these and how it affects the operations of the gas turbine. So once the fuel system operation is not efficient or effective, that will reduce or affect the efficiency of the gas turbine, okay. So those circuitry that we saw earlier, they are all tied to this fuel system, okay. So the compressor performance, if the compressor is not delivering the right spec of compressed air to the combustor, of course, what will come out of the combustor at the end of the day will not be as required for the turbine itself to produce the needed power output, okay. And the right air fuel ratio or mixture will not be able to get there if we have issues with the performance of the compressor. So as we'll see later, the compressor, there are some issues that can happen within the compressor. Imagine that maybe we have contaminated air coming into the compressor, which will later lead to deposits on the compressor blades, the rotor blades, or even the stator blade. What that will mean is that it will reduce the efficiency, in that it will reduce the volume, okay, that is available for compression to be done within the compressor. Are we getting it? So it will generally affect the efficiency, apart from the fact that will bring in dirty air to the combustor and affect the combustion product. In fact, affect combustion itself, because we will not have the right air fuel ratio within the combustor. So the compressor performance can also cause reduction of power that we will have at the output of the gas turbine. Then the turbine itself, its performance, okay, can also affect the output. If it is not efficiently converting the energy that is contained in the combustion product as it's flowing through it into rotating mechanical energy, that will affect the output that we will also get. So a lot of things can result to such loss of efficiency, especially in the turbine. So when we get to the turbine issues section, that is the section on turbine issues, we'll discuss some of these things that can cause that loss of efficiency or performance, reduce performance of the turbine section. Then the combustion chamber, if we have issues with the combustor, we have issues with the fuel nozzles, we have issues with the igniter, we already have the right air fuel mixture, ignition phase to take place. That means combustion will not take place. Once combustion does not take place, it means that that combustion product that will be required from that combustor will not be there. So we will now turn in dangerous air fuel mixture into your turbine that can cause an explosive condition, or that can develop an explosive condition that is detrimental to the safety of the operational environment. Okay. Then the exhaust system issues too can also affect the power output, as we discussed earlier. Okay, if the exhaust temperature is high, that will mean that the turbine is not working efficiently, it's not harnessing as much as it could the energy that is contained in the combustion product. So that will also affect it. And remember too, the rate at which combustion product, that is the exhaust, the combustion product, after going through the turbine section is flowing out, will also influence the rate at which compressed air is coming into the combustion chamber and then flowing through the entire process, the entire turbine system. Okay, without causing hindrance on the flow part or flow system. So we'll look at that as we go along. Then the auxiliary system issues, lubrication system, the fuel system as we saw earlier, okay, the cooling system, all of these can affect the efficiency of the gas turbine. So what are some of the remedies? What are some of the things that we can do to take care of all of these problems? One, we want to carry out comprehensive inspection when we have the opportunity, or during our routine or normal preventive maintenance inspection. Okay, so once we have that, once we come to that period, we should not skip, even if the turbine is functioning properly. So during that inspection, if there are problems with any of the systems or subsystems of the gas turbine, we'll come to see them and then carry out the necessary maintenance action to remedy the situation before they develop into problems. Then performance monitoring. During normal operations, there are some performance parameters that we need to be looking at. The pressure of the air into the pressure, the temperature, the humidity, okay, of the air that is coming into the gas turbine through the suction or the intake plenum, okay. Then the discharge temperature of the gas compressor, which is the discharge pressure of the gas turbine. Those are performance parameters. Okay, then the temperature of the combustor, the temperature at the input of the turbine, the temperature at the output of the turbine, at the exhaust. All of those, temperature and pressure, all of those are performance parameters that we need to be looking at, so that when problems are arising, on these performance parameters, they are going out of what is specified, okay, we need to take the necessary actions to bring them back operationally, to bring them back into what is needed for the normal operations of the gas turbine. Then if maybe as we are doing that, it is deteriorating further, of course, in the next inspection and maintenance section on the gas turbine, we want to do what is necessary to rectify the problem. So all of these performance parameters, all of these parameters that we are getting, they are not for fancy, that we are gathering, okay, from the operations of the gas turbine. They are not for fancy or for decoration. We need to be looking at them, analyzing them from time to time to see if any trend is developing. So if we notice any trend, if the trend is negative, of course, we need to do what we can to ensure that we reverse that trend from the information that we get. So if it is something that we cannot do within our facility, we want to call in an expert, okay, to tell us precisely from the data that we are getting what is actually happening with our machine, gas turbine. So with that, we will be able to infer what is happening and what could be done to rectify the situation. Then our preventive maintenance schedule, as we said earlier, we do not want to miss it for anything. Okay, the normal routine inspection, change of filter, both fuel and air filter, the change of the oil, coolant, lubricants, and what have you. Okay, so we want to maintain that normal PM schedule on the gas turbine. So all of this will actually help to maintain the efficiency of the gas turbine. Remember that the PM, what informed the PM is the fact that some of these components would have gone into the wear stage, okay, in their life. That's from expectations, okay. So at those times, it is recommended to do change out or to carry out some remedial action to reverse the trend. Are we getting it? So that is what informed the recommendation that we got from the manufacturer. So the idea is that before those components goes into that wear out stage, before it will eventually fail, we should change out. So we do not want to play with the preventive maintenance. But of course, from experience within our facility, if it is something that we need to change or to adjust, we will also see and adjust, do the necessary adjustments, okay, to fit our particular operations. Then the increased exhaust gas temperature, that's the temperature from the exhaust gas that is discharged, okay. So what can cause the increased exhaust gas temperature? So once we have combustion issues, are you getting it? That is, there are so many things. From our earlier discussion, we said the compressed air that is sent into the combustor, a percentage of it is used for combustion, while other percentage is used for cooling, okay. So when we do not have that enough quantity of compressed air, what will happen? That will increase the temperature of the combustion product that is leaving the combustion chamber to the turbine, okay. So as it's going out, you see the turbine will take as much as it could, the rest will come out excessively hot. So increased exhaust gas temperature is an indication of issues within the turbine itself. Then it is also possible that the fuel that we are having is not of the right specification, okay. So the combustion effect or the rate at which it's burning is not as desired. Are we getting it? So it can also affect the combustion, the energy that is contained in the combustion product. So issues with the combustion chamber or the combustor can affect what we are having at our exhaust gas. Then compressor surge or stall, okay. So surge or stall is like a back pressure in the compressor section that prevents the compressed air from going in through to the combustor. Are we getting it? So if that happens, that will affect the amount of the volume of compressed air discharged into the combustor. Okay, so once that happens too, what we explained earlier can still happen, and of course it will affect the exhaust gas temperature. So surge or stall, they have so many issues associated with them. Are we getting it? Especially surge. Apart from increasing vibration, it can cause this increase in exhaust gas temperature. Okay. So turbine problems too. Once we have fouling on the turbine blades, we have broken blades. Okay. Then we have blades that are fagged out. They are not able to absorb most of the energy that is coming from the combustion product and converting them into rotating mechanical energy. You see that all of those energy will move through to the exhaust. Okay. So once there is problem with the turbine, the fuel quality, as we explained earlier, can also affect the exhaust gas temperature. Air filter clogging. Once the air filter is plugged, it means that what is coming in, okay, will be reduced, the amount of gas. So we will not have sufficient air to be compressed by the compressor, and then we will not also have the required we will not be able to attain the required pressure at the compressor discharge into the combustion chamber, which will also affect the air fuel ratio or mixture ratio, okay, at the combustion chamber. So all of this can result to increase exhaust gas temperature. Cooling system issues. When the cooling system is not effective, it is very clear that it can also result to increase exhaust gas temperature. So what can we do to stem that tide? First, we want to optimize the fuel air mixture. Okay, so you saw the control, the F there is the fuel control system or the fuel system that we showed earlier. Okay, that control system, we want to optimize it so that the air fuel mixture will be at its optimum. Okay, so we also want to look at the quality of the fuel too. Are we getting it? Which means that our fuel system, we need to maintain it so that it will be functioning properly, okay, to enable us to operationally optimize that fuel air mixture. Then we also want to improve fuel injection, which is also maintaining the fuel system. That is, the fuel injector have to be functioning properly. Okay, if it's expected to atomize the fuel further, it needs to atomize that fuel to the appropriate level. It needs to inject the appropriate amount of fuel when it has the required pressure at its input. Okay, so we need to ensure that too. Then the ignition components, we need to be inspecting them. That is the nozzle itself, the fuel injector itself, the lighter or the igniter. Okay, we need to be inspecting them. Then the liner in the combustion chamber, we also need to be inspecting them at regular interval to see that none of them is damaged or blocked. Then once we have compressor issues, we want to take care of them. Operationally, we can take off a surge or stall. Okay, the inlet guide vane is there to assist us. Okay, to assist us in controlling surge. Then the bleed valve is also there for us to also control such abnormal conditions during normal operations. So in our training on startup, we'll see how what's during startup the function of the bleed valve, what it will help us to achieve, okay, during the startup also. Then the turbine blade at regular interval and the um, at any available opportunity too. Okay, we want to inspect this blade to see that nothing is wrong with them. So we want to carry out BORESCOPE inspection on this blade, even the compressor blade too. Look at if there are deposits on them. Look at if there are signs of distress in them. Look at if there are cracks, breakage, or uh, missing blades in the rotor. Okay, so all of these we want to be sure of. Then the fuel also, we want to ensure that the fuel meets the quality standard that is recommended for the operations of that particular gas turbine. So if it meets it, we will not have much of a problem in the area of the fuel. Okay, then we want to have a regular maintenance schedule for the air filter, okay, the intake air filter, and also the fuel filter that is in the fuel system. Okay, so the next that we'll be looking at is the compressor issue. The compressor, remember the function of the compressor to generate compressed air that we actually need in the combustion chamber. So what are some of the issues that are associated with the compressor during operation? Reduce compressor efficiency. Reduce compressor efficiency, not giving that is the compressed air coming out of the compressor will not be of the right temperature or pressure. Those are the two basic things that we look at, okay, from the compressor. Then surge or stall, as we said earlier, like a back pressure. So these are the guide vanes, okay, that could be adjusted to adjust the amount of air that is administered into the compressor chamber to help us avoid stall. So these are the variable guide vanes that we said earlier. Okay, so these variable guide vanes, if we are having that kind of back pressure, is to reduce the amount of air that is administered into the compressor so that the volume that is compressed will be reduced. Okay, so that it will allow time for the relieving of the excess pressure downstream the compressor. Are we getting it? So that the surge will be taken care of also with stall. So this variable guide vane, they are connected to the stationary blade. Okay, so they have the capability of changing the orientation of the blade to either widen the space between them or close the space between them. So widening the space between them increases the volume of that stage or of those stages where we have the variable guide vanes. Then closing the space between them reduces the volume, okay, of those stages of compressor, thereby reducing the amount of air that is compressed. Then high compressor discharge temperature. Okay, high compressor discharge temperature, that is another issue with the compressor. Could be another issue with the compressor. Remember, by virtue of the nature of its functioning, compressing the air will invariably increase the temperature of that particular air. Okay, so that temperature, it has the normal level, because if the temperature is too high before we send it into the combustor, that will further increase the temperature of the combustion product, which will mean that we will have increased exhaust gas temperature. Are we getting it? And again, it can also affect all other components downstream. So we need to maintain the temperature of the compressor at the discharge, okay? The discharge temperature of the compressor. So in maintaining the discharge temperature, we want to ensure that the temperature of the air that is coming into the compressor is right. Are we getting it? We want to make sure that it's right. If it is right, that will mean that after compression, the temperature will not go above what is done. But if it is higher than what is expected, if it is lower, fine. But remember too that the lower the temperature, the higher the quantity, or the higher the number of air molecule per unit volume. Okay, since the temperature is lower, they have lower kinetic energy to move off. Are we getting it? And that increased volume of air, when you send it to the compressor too, that can cause issues like that surge or store that we discussed earlier, because more volume than required is sent into the compressor. So we want to maintain those operational parameters as much as possible at the required level. Okay. So excessive vibration can also result to compressor issues, and this vibration can be caused by surge, can be caused by problem with the rotor, imbalance, misalignment, broken blade, okay, or a blade that has gone off, cracked blade. All of these, they can result to increased vibration. Are we getting it on the compressor? So seal leakage. Once there are leakages, okay, once we have leakages of compressed air, you'll see that that will reduce the efficiency of the compressor. Okay, so we need more work to get to the required level. So seal leakage is one thing that can also cause compressor issues. So we want to guide against seal leakage, or when we notice it, we can shut down the unit and then replace our seal. So these are the bleed valves, okay? So in during startups, they are used to purge the compressor, and even those are the turbine stage too, to purge the turbine and the compressor, so that if we have any fuel that is left, residual fuel in the combustion chamber, okay, those will help to send all of them away. So you see that it is connected to the 6th and the 10th stage of the compressor, and then it is sent straight to the exhaust. Are we getting it? So these are the bleed valve. They are meant to also control surge, okay, within the compressor. So the combustor too, they could have issues as we discussed earlier. Okay, so some of the issues that it could have, maybe incomplete combustion within the combustion chamber. Okay, so if the air fuel mixture is not completely combusted, that can result to secondary combustion. And that secondary combustion, if it happens in a wrong place downstream, it can cause damage of the turbine system. Okay, so imagine that you have the fuel that is not completely combusted, okay, sent into the turbine, and then that mixture is now combusted within the turbine. All of those can lead to undesirable conditions that we actually do not want. So incomplete combustion can also generate combustion gases that are poisonous, okay, to the atmosphere. So we do not want such to happen. So we want to ensure that our combustion system the fuel system is functioning properly. The igniter will ignite at the right time. Then the injector will give the right amount of fuel. We inject the right amount of fuel into the combustion system. So it is possible that the combustor too can develop hot spots. If we have deposits on them, that is, yes, deposit on them, those spots could develop. Those where we have those deposits, those spots can generate excessive heat that is higher than the surrounding, and that excessive heat can damage the material, okay, the component of the combustor at that particular point, that can lead to deterioration and eventual failure at that particular point. So, or eroded part of the combustor too can show up as hot spots, okay. So when we say hot spot, that is the spots that have temperature that is higher than normal, what is expected around that combustor or that area where you find that particular spot, okay. So those are hot spots. Then the liner could be eroded, let me say, probably because of dirty compressed air. Your intake filter is failing, so those debris that will be sent into the combustion chamber can erode the liner, okay. So those can cause liner erosion, or even your fuel. If your fuel is dirty too, as it's injected, combusted, and then as it's rubbing on the wall of the combustion, the combustor liner, those can cause erosion or wear of the liner. Fuel nozzle clogging or wear as a result of dirty fuel, okay, it can cause clogging at the nozzle. The ignition problem, when you want the igniter to ignite, it will not ignite. Are you getting it? So you see that more than enough fuel will have been injected, distorting the air-fuel ratio, okay, before ignition will now finally take place and cause serious issues within the compressor. So here are some of the problems, summary of some of the problems: incomplete combustion, hot spots, liner erosion, nozzle clogging, and ignition problems. Here are some of the possible causes: poor fuel air mixture ratio, okay, then incorrect fuel air ratio, then ignition problems, improper fuel nozzle spray pattern, as we discussed earlier. So the remedies: optimize air fuel mixture, adjust air fuel ratio, and check your ignition system, inspect and clean fuel nozzle. So you can go through this, you can pause and go through all of this. So these are some of the remedies for these problems, okay. So here we see some of the things that can cause clogging: carbon buildup. As the fuel is combusted, if the fuel is not too clean, it can result to the deposition of carbon at those nozzle tips. So, and that can cause plugging. So we want to look at blade issues now, the turbine blade issues. So the turbine blade can also have issues, okay. They are the ones that are in direct line of fire, as you can see here, okay. So as it's leaving, as the combustion product is leaving the combustor, goes into the turbine blades, both the stationary and the rotating blades, they receive the direct heat. So what are some of the issues that could be associated with these turbine blades? So thermal fatigue. The thermal stress can lead to fatigue. The hot air coming in, then less hot air that will cause, in fact, that steady heat that will cause the expansion, okay, of these turbine blades. So if there are defects within the materials used on these blades already, you see that because of this thermal stress, okay, the those anomalies within the materials will come out. Are we getting it? Then the fatigue, in the sense that as you are heating like that, the normal strength of the blade material itself will eventually be lost. So once fatigue sets in, it can cause the loss of that particular blade. And that fatigue too can also, that normal heating can cause creeping of the blade material, okay? So we have creep effect. Then corrosion too can also happen. That is, maybe your fuel is not clean, or the air that is coming in is not properly dry, okay? Or the fuel is not of the proper specification. It contains acid gases. So all of these acid gases, once they combine with oxygen, they can cause corrosion around these blades, and those corrosion can lead to early fatigue and you losing that particular blade or damaging the blade. Erosion too, dirty fuel, dirty compressed air, are we getting it, can result to erosion on the blade itself. And once the blades they are eroded, it means that the cross-sectional area at those points will have been reduced, and that will compromise its ability to withstand the thermal stress that it will be subjected to. So that is one thing that we really need to take care of. Then high cycle fatigue, okay? So since it is subjected to repeated high temperature, are you getting it, all the time? So that temperature at that high level fluctuating, that can result to fatigue that will eventually lead to blade failure or issues with the blade. Then vibration too. If there are excessive vibration too, they can lead to high cycle fatigue, okay? That will eventually lead to your losing those blades. Then low cycle fatigue, maybe you're having too frequent startup. Are we getting it? Too frequent startup on the gas turbine itself. They can lead to those low cycle fatigue. So like we said earlier, the BORESCOPE, okay, will help us to look into the turbine for us to see the blade and see what is happening with the turbine blade, even the compressor too, okay? So the BORESCOPE, you see that it has this is a fiberglass, okay? Then there is the light that is coming through here. There is a camera here. As you are looking at it, it will be transmitted. What you have, the image will be transmitted to the BORESCOPE. That is the BORESCOPE, and then you'll be seeing it on your screen. Are you getting it? So when there are BORESCOPE inspection openings or slots within the turbine itself, that is the gas turbine. In the compressor section, we have such inspection holes, okay? Then we have at the turbine section too. So we insert this into the inspection hole, and it will help us to see the internals, as you can see here, okay? So these are the blades of the turbine, okay? So if there are issues with the blade, you see them clearly. If you have corrosion, erosion, cracks, or broken blades, you see them clearly. And then that will inform what you need to do next. So the BORESCOPE inspection is to enable us to look the internal parts of the turbine, okay? The entire unit, both the compressor and the turbine itself. We can even inspect the combustion chamber or the combustor, okay, with the BORESCOPE when the unit is off. Usually it is done when the unit is shut down, okay, or when we have any opportunity when the unit is not working. We can do that BORESCOPE inspection. So control system problems too can affect the operations of the gas turbine. Okay, we saw the one on the fuel control. So if it is not still working optimally or efficiently, it will affect the fuel injection system into the turbine that will eventually affect the efficiency of the turbine itself. So what are some of the issues, okay, that are common with the control system? Remember, we have other things to control. The lube oil system is controlled. The starting system is controlled. Okay. The 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 pressure of the lube oil system or the cooling water system also is also controlled. So there are instruments looking at all of the pressure and the temperature of all of this system and trying to maintain them at what is normal, at the level that is normal for the operations of the gas turbine. So what are some of the issues? Those sensors, they could malfunction, and once they fail, they will not be giving us a true representation of what is happening within the gas turbine. And once that happens, it means that we will not be operating the gas turbine at the optimal level. Then actuator malfunctions, okay? Maybe a particular solenoid or a particular motor that is expected to open up a valve. Are we getting it? It's not functioning properly or it's malfunctioning. It can also affect the operations. Then the control error, control logic error can also give false signal or incorrect signal, okay, to the control system that will affect the operations of the gas turbine. Then the hardware failures too, the valve, the motor, any of the hardwares that are responsible for affecting the control, okay. So like the solenoid controlling these guide vanes, it could fail, and you want to adjust the guide vane to regulate the amount of air that is coming in. What will then happen? Or the bleed valve, the valve fails to open when you want it to open. Okay, so such hardware failures can affect the operations of the gas turbine. Then communications issues between these components can also affect the gas turbine. Environmental factors can also introduce control system problems. Okay, so maybe the environmental condition is too stringent. That will kind of affect the operational parameters that is expected in that area, and that will affect the functioning of the gas turbine. Auxiliary systems, like we said earlier, the fuel system, the lubricating oil system, and the cooling system, okay, all of these can have some faults. That is the cooling system fault. Maybe we have a clogged heat exchanger that is expected to take away the heat that the cooling, if it is cooling water, cooling air, or even lubrication oil, okay, take the heat away. It's not doing that effectively. So the lube oil system can also lose pressure because the lube oil pump is failing. Okay, though we have two pumps in the system, we have the one that is mechanically driven, that is the main pump, and then we have the auxiliary pump, okay, that is meant to come in when the loop oil pressure is going down below some levels. So the loop oil system too, if it is malfunctioning, the fuel system as we saw earlier, then the protection system too, okay. There are some conditions that are not allowed in the operations of the gas turbine. So once that conditions they start developing, it's expected that the gas turbine should shut down. Okay, so that protection system, there could be faults in them, and if they are not there, it means that when such conditions are developing, it will not see that condition, and the condition will develop and destroy the gas turbine. So we want to ensure that our protection system, they are functioning optimally. Okay, the overspeed, high temperature, vibration, are we getting it? Loop failure, loop pressure level, cooling system. Okay, so once the cooling system pressure goes below certain level, and the protection system should kick in. The fire and gas, that is the fire protection system too. Okay, all of them should be functioning optimally.